Welcome to MRI Physics, Scan Principles. Image Formation. There will be 60 questions and answers and multiple choice on image formation and sampling. Information is credited to MRIquiz.com, Quizlet, and MRI in Practice. I highly recommend you subscribe to MRIquiz.com to study for your MRI board. Now, take a deep breath. Here we go. When the receiver bandwidth is increased, what happens to the chemical shift and slice thickness? A. Increases chemical shift artifacts. B. Decreases chemical shift artifacts. C. Decreases slice thickness. D. Increases slice thickness. The answer is B. B. Decreases chemical shift artifacts. Note: increased receiver bandwidth decreases the chemical shift in metal artifacts, decreases SNR, decreases scan time, and has no effects on slice thickness, SAR, and spatial resolution. How does changing the slice thickness affect the T2 contrast? Decrease, increase, or no effect? The answer is no effect. Increasing the slice thickness does what to the spatial resolution? Decrease, increase, or no effect? Increasing the slice thickness decreases the spatial resolution. The slice thickness determines the depth of the voxel. This is almost always the largest dimension of the voxel in 2D imaging. Therefore, the resolution perpendicular to the image plane is the poorest. The orientation of the main magnetic field of a low-field permanent magnet is vertical. True or false? True. Increasing TR will increase A. SNR. B. Scan time. C. Number of slices. D. All of the above. E. Just A and B. The answer is D. All of the above. Decreasing receiver bandwidth by a factor of 2, choose one of the following answers below. The answer is D. Increases SNR by the square root of 2. Applying 2 gradients simultaneously during slice selection would A. Produce an artifact. B. Produce an oblique slice. C. Produce partial volume averaging. D. Result in an equipment fault. The answer is B. Produce an oblique slice. Increasing the TE has what following effects? Pause the video. The answer is option G. B and D only. Decreases the SNR of the image. And increases the contrast based on T2 relaxation times. Decreasing the slice selection gradient strength will have what effect below on the resulting slice? Choose one. The answer is B. Change the slice thickness. Remember, slice selection gradient is the determinant of scan plane and slice thickness. Slice selection gradient is inverse to slice thickness. And, in order to generate an MR image, the slice select gradient must be turned on during the RF energy application. Reducing the TR has what following effects below? Pause the video and choose one. The answer is F, B and D only. Note: reducing the TR decreases the SNR of the image and increases saturation effects. And 3 direct relationships of TR, SNR, scan time, and number of slices. How do you obtain a thin slice thickness? Pause the video and choose one. The answer is C. A steep gradient is applied with a transmit bandwidth at the Larmor frequency of h. Things to remember: increased, steep, slice select gradient equals thin slices. Decreased slice select gradient equals thick slices. All applied to transmit bandwidth. Presaturation pulses are often used to A. Improve spatial resolution. B. Improve temporal resolution. C. Reduce scan time. D. Reduce flow artifacts. E. Enable bright signal from flowing blood. The answer is D. Reduce flow artifacts by increasing the number of saturation bands. Creating additional images in various planes from a 3D dataset is accomplished by a technique known as? Choose one. The answer is B. Multiplanar reconstruction, MPR. The presaturation pulses typically are found where? Choose one below. The answer is D. Prior to the excitation pulse. Note: a presaturation pulse excites hydrogen protons to a frequency that gives no signal on the image. This occurs prior to the excitation pulse. When gradient moment nulling is used as an imaging option in MR sequences, what is the effect below? You should pause the video and think for a few seconds. The answer is B. The minimum TE is increased. Explanation: applying gradient moment nulling flow compensation requires a longer minimum TE is used. Gradient moment nulling flow compensation is used to compensate for first-order motion, protons moving with constant velocity, and slow-flowing vessels. Reducing the TE affect what below? Please pause and think carefully. The answer is C. Decreases the contrast based on T2 tissue relaxation times. As we learned earlier, TE has an inverse relationship with SNR, and TE has a direct relationship on T2 contrast. As the flip angle is increased, SNR decreases, increases, reduces to the minimum allowable Tesla, or unaffected. The answer is B. Increases to a point called the Ernst angle. As the TR is increased, how does it affect below? Pause the video and think. The answer is A. A 1 and 2 only by increasing SNR and number of slices. Remember, TR controls T1 contrast, not T2. Gradient moment nulling is used to compensate for A. First-order motion, B. Second-order motion, C. Slow-flowing vessels, D. Fast-flowing vessels, E. All of the above. F. A and C only. G. A, C and D. The answer is F. A and C only. Gradient moment nulling compensates the first-order motion and slow-flowing vessels. Which set of scan parameters below would yield the best spatial resolution? Please pause the video and think. The answer is C. A small field of view, big phase matrix, and smaller slice thickness yield high spatial resolution. NEX has no effect on spatial resolution. Choice C meets these criteria. Signal-to-noise ratio would increase in a 3D volume acquisition with an increase in A. TE, B. Slices, C. Field of view, D. All of the above. E. B and or C only. The answer is E. Slices and field of view only. TE has an inverse relationship with SNR. TE would be decreased, not increased. Gradient echo sequences use flip angles, A. to control saturation effects, B. after the 180 degrees pulse, C. between the 90 degrees and the 180 degrees pulses, D. to control SAR in bariatric patients. The answer is A. to control saturation effects. Gradient echo sequences use flip angles to control saturation effects, and lacks 180 degrees refocusing pulse, therefore, more susceptible to inhomogeneities. A technique that reduces scan time by not filling as many lines of case space in the phase direction, while maintaining spatial resolution, is known as A. Rectangular FOV, B. Parallel imaging, C. Partial saturation, D. Dual inversion recovery. The answer is A. Rectangular field of view. Parallel imaging is a scan time acceleration technique, which requires using a phased array coil to reconstruct an image in less time than conventional imaging. Complete saturation is a condition where A. Spin density effects dominate contrast, B. The signal from fluid is inverted from a long T, C. Transverse magnetization is not allowed to recover between excitations, D. Longitudinal magnetization is not allowed to recover between excitations. The answer is D. Longitudinal magnetization is not allowed to recover between excitations. Note: suppresses longitudinal magnetization when NMV is flipped full 180 degrees. Which of the following can be considered an advantage of selecting a 3D acquisition as opposed to a 2D acquisition? A. The slices have a greater SNR. B. No crosstalk. C. Longer repetition times. D. All of the above.
E. A and B only.
E. A and B only. Because repetition time is the controlling factor of T1 contrast, and has a direct relationship with scan time. Long TR equals higher scan time. 2D acquisitions usually require A. Flow compensation. B. Presaturation slabs. C. Fat suppression. D. An interslice gap. The answer is D. An interslice gap. Decreasing or narrowing the receiver bandwidth, A. Increases the contrast based on T1 tissue relaxation times. B. Decreases the SNR of the image. C. Increases the SNR of the image. D. Inverts the SNR of the image. E. Does not affect the SNR of the image. C. Increases the SNR of the image. Receiver bandwidth has an inverse relationship with SNR and scan time. What effect would decreasing the field of view have on the spatial resolution of an image? Decrease, increase, or none? B. Increase. Only one inverse for the field of view is spatial resolution. The range of transmitted frequencies at each slice position must what to maintain slice thickness? A. Remain constant. B. Increase with each slice. C. Decrease with each slice. D. Disable, then re-enable. The answer is A. Remain constant. In a gradient echo sequence, reducing the flip angle while maintaining the TR reduces A. Scan time. B. T2 star contrast. C. Inversion delay. D. Saturation. The answer is D. Saturation. Gradient echo sequences use flip angles to control saturation effects. Reducing the flip angle also yields images with less T1 information. Flip angle is the angle to which the longitudinal magnetization is tipped into the transverse plane, following the initial RF excitation pulse. Two gradients applied at the same time during slice selection are utilized for A. Reducing the cryogen boil-off rate. B. Encoding oblique slice planes. C. Eliminating residual transverse magnetization for steady state. D. Encoding 3D volumes for MRI. The answer is B. Encoding oblique slice planes. Multiplanar reconstructions are typically utilized in 3D pulse sequences because A. 2D slices are too thick to reformat. B. 2D slice groups are too long. C. There are gaps between 2D slices.
D. A and C only. E. B and C only. The answer is D. A and C only. The option to reconstruct multiple planes from a single dataset is advantageous in a 3D pulse sequence, due to the thin slices used in 3D sequences, and the lack of the interslice gap. To increase the voxel volume, which parameters would be adjusted? A. Slice thickness and interslice gap. B. Matrix, slice thickness and slice gap. C. Field of view, slice gap and matrix. D. Field of view, slice thickness and matrix. The answer is D. Field of view, slice thickness and matrix. Decreasing the receiver bandwidth. A. Reduces readout time. B. Increases readout time. C. Does not affect the readout time. D. Increases SNR. E. A and D only. F. B and D only. The answer is F. B and D only.
Remember that the receiver bandwidth has an inverse relationship with SNR, scan time, and readout time. Increasing SNR, scan time, and readout time increases the sampling time and lengthens the sequence timing, creating longer minimum TR and TE values. If the maximum slices in a set TR is 10, and the necessary number of slices for a given sequence's anatomical coverage is 26, how many acquisitions packages will be required? A. 1. B. 2. C. 3. D. 4. The answer is 3. How do you get that? If anatomical coverage is 26, and the maximum TR is 10, you can find the number of packages by taking 26 divided by 10. You get 2.6 acquisitions. You round off 2.6 to 3. Decreasing the receiver bandwidth. A increases susceptibility artifact. B decreases susceptibility artifact. C does not affect susceptibility artifact. D decreases SNR.
E. A and D only. F. B and D only.
The answer is A. Increases susceptibility artifact. Once again, receiver bandwidth has an inverse relationship with SNR, scan time, and chemical shift and metal artifacts. But it has the direct relationship with sampling rate and number of slices available. What below is defined as a small change in the magnetic field along a particular axis. A. Analog to digital converter. B. K-space. C. Fourier transform.
D. A gradient. The answer is D. A gradient.
Which of the following statements is false regarding the use of a narrow receiver bandwidth? A. It generates lower signal-to-noise ratio images. B. It should be applied in anatomical regions that contain high fat and water interfaces. C. It is utilized with a high readout gradient amplitude. D. All of the above. D. All of the above are wrong. Receiver bandwidth directs only in sampling rate and number of slices. Lower bandwidth equals higher signal-to-noise equals more chemical shift. A wide, not narrow, receiver bandwidth should be applied in anatomical regions that contain high fat and water interfaces. If the receiver bandwidth is decreased, the sampling rate A increases, B decreases, C increases by the square root of 2, D does not change. The answer is B, decreases. The two have the same direction as we mentioned in previous questions. Increasing the receiver bandwidth has what effect on chemical shift? The answer is B. Decreases chemical shift artifacts. It does not affect slice thickness. All of the following are true mechanisms of saturation except
A. A presaturation pulse excites hydrogen protons to a frequency that gives no signal on the image.
B. Partial saturation yields T1 weighting, occurs when NMV greater than 90 degrees. C. Partial saturation yields T1 weighting, occurs when NMV is 180 degrees. D. Full saturation suppresses longitudinal magnetization, occurs when NMV is 180 degrees. The answer is C. Partial saturation yields T1 weighting, occurs when NMV is 180 degrees. What effect would using a steep slice select slope and or narrow bandwidth have on slice thickness? A. Partial volume averaging will occur. B. Slices will be thin. C. Slices will be thick. D. Slices will crosstalk. The answer is B. Slices will be thin. Decreasing the receiver bandwidth. A. Increases the number of slices available. B. Decreases the number of slices available. C. Does not change the number of slices available. D. Decreases SNR.
E. A and D only. F. B and D only.
The answer is B. Decreases the number of slices available. The sampling rate, number of slices available, and noise sampled are the only direct effect of receiver bandwidth. Receiver bandwidth has no effect on the slice thickness. The maximum intensity projection algorithm A. Separates the K-space phase and frequency modulations into images. B. Subtracts a mask from a contrast image, leaving only blood vessels. C. Projects the high-intensity pixels which represent blood vessels, ducts into one image. D. Calculates the frequencies required for 90 degrees and 180 degrees RF pulses. The answer is C. Projects the high-intensity pixels which represent blood vessels, ducts into one image. Slice. What is determined by the slice selection process? A. Position. B. Orientation. C. Thickness. D. All of the above. D. All of the above. Slice selection gradient has an inverse relationship to slice thickness. In order to generate an MR image, the slice select gradient must be turned on during when A. T1 relaxation. B. Collection of the echo. C. Patient positioning. D. RF energy application. The answer is D. RF energy application.
If the radiologist requires 3 mm slices axially acquired through the IAC, with a slice gap of 0.5 mm, and requires 4.2 cm total coverage, how many slices must be selected? A. 6. B. 9. C. 12. D. 15. The answer is 12. First, you add the slice thickness to the gap, 3 mm plus 0.5 mm equals 3.5 mm. Then, you convert the 4.2 cm total coverage to millimeter, 4.2 times 10 equals 42. Finally, you take 42 divided by 3.5 to get 12 slices. What is the file on the computer where the collected echoes are stored prior to being processed into an image by the Fourier transform? A. Analog to digital converter. B. Raw data. C. K-space. D. A gradient. The answer is B. Raw data. An isotropic voxel refers to a what-shaped voxel? A. Circular. B. Rectangular. C. Cubic. D. Oval. The answer is C. Cubic. An isotropic voxel has equal measurements in all three dimensions: phase, frequency, and slice direction. Which factors affect the flip angle? A. Gradient slew rate and the magnetic field strength. B. Duty cycle and RF field. C. Strength and duration of the RF field. D. Static magnetic field and gradient rise time. The answer is C. Strength and duration of the RF field. The readout gradient is usually turned on during the sampling or readout of the peak echo, and also during which other process? A. Slice selection. B. Phase encoding. C. Frequency encoding. D. None of the above. The answer is C. Frequency encoding. Frequency, readout gradient controls sampling time, which is the time needed to sample entire case baseline. The time during which the frequency encoding gradient is on, A. Increases with a reduction in receiver bandwidth. B. Decreases with a reduction in receiver bandwidth. C. Is not affected by a reduction in receiver bandwidth. D. Is limited by the inverse of the gradient slew rate. The answer is A. Increases with a reduction in receiver bandwidth. Inverse relationship, gradient on time increased with a reduction of receiver bandwidth. The time during which the frequency encoding gradient is on increases with a reduction in receiver bandwidth. If 24 of 4 mm slices are planned with a gap of 1 mm, the total anatomic coverage is how many cm? A. 10. B. 12. C. 15. D. 120. The answer is 12. First, add slice thickness to gap. 4 mm plus 1 mm equals 5 mm. Then, multiply 24 slices to 5 mm. You will get total coverage of 120 mm. But, the question is ask the coverage in centimeters, therefore, you must convert 120 mm to cm by dividing by 10 to get 12 centimeters. The signal produced immediately following an RF pulse is A. Ham radio signal. B. Gradient echo. C. FID. D. MIP. The answer is C. Free induction decay. Which of the following is not a result of reducing the field of view? A. Improved spatial resolution. B. Decreased signal to noise. C. Anatomical structures are displayed smaller in the image. D. The pixel size becomes smaller. C. Anatomical structures are displayed smaller in the image. Anatomical structures are displayed larger with a reduction in the field of view. The process that digitizes the MR signals is known as A. Hahn echoes. B. Faraday's law. C. Gyromagnetic reconstruction. D. Fourier transform. The answer is D. Fourier transform. A narrow receiver bandwidth. A. Decreases susceptibility artifact. B. Increases susceptibility artifact. C. Lowers SNR. D. Should be used in the presence of metal implants. The answer is B. Increases susceptibility artifact. A and C would be examples of a direct relationship, which is false. The only direct relationships in receiver bandwidth are sampling rate, number of slices available, and noise sampled.
A what is defined as a picture element and has what characteristics? A pixel, 2-dimensional. B pixel, 3-dimensional. C voxel, 2-dimensional. D voxel, 3-dimensional. The answer is A pixel, 2-dimensional. The Ernst angle can be defined as the optimal what that yields the max or minimum signal for a particular spin in the least amount of time. A NSA minimum. B TR maximum. C flip angle minimum. D flip angle maximum. The answer is D flip angle maximum. Increasing the field of view would have what effect? A. Decrease spatial resolution. B. Increase spatial resolution. C. Decrease temporal resolution. D. Increase temporal resolution. The answer is A. Decrease spatial resolution. The only inverse relationship field of view has is with spatial resolution. A steep phase gradient causes A. A large phase shift. B. A small phase shift. C. No effect on phase shift. The answer is A. A large phase shift. Did those questions make your head spin? You made it. Good luck on your exam. Stay happy and positive. You will do great. Thank you for watching this video. Test your knowledge with the multiple choice questions. Kindly like, share, comment, and subscribe. That will motivate me to make more videos.